Okay, so on Wednesday I talked about getting one more tool that we have to work with. Then we talked about all those different weapons, which was fun for me. I don't know if you enjoyed it or not, but for me it was good to find out that I was wrong on some of them. However, we do have another thing that I want to show you today that will hopefully make your life a little bit easier, and it's called logarithmic differentiation. Okay? So, here's an example. Now, if you just look at that function for a second, you all have the skills to take the derivative of that function. The problem is, hopefully you can appreciate how absolutely nasty that derivative would be. I've got a quotient rule with two chain rules wrapped up inside of it. Now, is it doable? Absolutely. But it's much more doable using logarithmic differentiation. So the steps for logarithmic differentiation are outlined there at the bottom. My OCD is kicking in, and I don't know why the 1 isn't also blue, but I'll try to work around it. Now that I pointed out to you, you can also enjoy that little tidbit of information. Okay, so it's easier to see in action, so I'm just going to solve this problem on the next slide. Everybody good? Got this? Okay.
That's fine.
Take the natural log of both sides, differentiate, solve for y prime. That's it. Okay? I just phrased it more fancily. Okay, here we go. Take the natural log of both sides. Okay, now before we go any further, let me ask you a simple question. What's the derivative of the natural log of smiley face? Good. Smiley face prime over smiley face. Okay, which is absolutely ridiculous, but it will help us solve this problem. Okay, before I take the derivative, I'm going to use my log properties. Nothing to do on the left-hand side. This, however, can be split into a difference. We good to go so far? Hot diggity. Let's do a little bit more. Yes? Okay, be careful with parentheses there. Make sure whatever you're taking the natural log of, you are keeping it inside parentheses so it doesn't. So you don't get the natural log of x plus 1 confused with the natural log of the quantity x plus 1. There's not much else I can do with my log properties, so now the calculus kicks in and I start taking derivatives of both sides. So what is the derivative of the natural log of y? Y prime over y. Okay, whatever that thing is, take the derivative of it and put it over itself. 2 times the natural log of x minus 2. The derivative of that is what? Please, one at a time. Over x minus 2. What's the derivative of x squared plus, what's the derivative of the natural log of x squared plus 1? Okay, clean it up a little bit. Well, what can I do to clean it up? That goes away with that. I got nothing else to clean up. Y prime over y is equal to 2 over x minus 2 minus x over x squared plus 1. Do we have to find a common denominator and simplify? No. But I still haven't solved for y prime yet, so I'm going to multiply both sides by y. I'm too lazy to rewrite it, so I'm going to do this. There we go. Am I done? No, why not? No, that would be, we don't want to do that. That would be disgusting. What's y equal to? So sub back in for y, and you get a final answer of 2 over x minus 2 minus x over x squared plus 1, all of that times x minus 2 quantity squared over the square root of x squared plus 1, and we're done. So sub back in for y there to finish the problem. Yeah. You don't have to simplify. Just leave it for now. Questions? Beautiful. Now you do this one. Go. What's the matter? Too fast? There. Back up. Hold on. I get people trying to keep up. Going too fast. Want me to give it the finger? Okay. Delaney, you good?
Yes, thank you.
Wow. Okay, go. Who is it you're talking to? Adrian. Oh. Did you say, oh, hey? Hey, what's happening? You here? You here? I'm here.
Hey, what's up?
Yeah, right.
Where the piece of cake?
Deal with it, face. Not everything in life is preset.
Duck queen. Okay. Oh, are you? Yes.
I have this on that thing, right? Yeah.
This makes learning duck fast.
What's that?
I did it for 4 years. I didn't have to get it.
Yeah.
What is this
Oh, brother.
I have no idea. We got the same answer. We got the same thing.
I like it. I see
We did it wrong.
But then that's your friend and mine missing product.
Oh,
yeah.
Okay.
Gasified. Can you define it for
It's
us?
just like, I heard you're better than anyone.
Okay.
Is it valid?
So like if I'm a teacher role,
Is it right?
I would be gasified.
Yeah.
Right, because I'm like the bomb.
You can't even help it.
Like kids days ago would have said the bomb.
Yeah.
Right, so gasified is like that dude's totally gasified.
Yeah.
Is this a word you made up?
I did not make it up, but
What, two?
a lot of people associate that word with me.
I understand.
Because like, say,
So if I was to post something on Instagram about something or something being gasified, they'd be like, hey, that's mine.
yeah,
That is not gasified. Product.
Want to see it?
Oh, you think so, huh?
Yeah.
Prove it. Go up to the board and do it.
Yeah, let's go here.
Go, Eric. Come on.
Adrian.
Come on, back it up. Let's go.
Me?
Talking a big game, Eric. Come on.
Okay, I feel like this. You know what?
I lose here.
This is right, right?
You can stay with what you know and use your finger on the board to make you feel comfortable.
Oh.
Don't look at me in that tone of voice, Eric. I'll knock you into tomorrow.
Okay. I can't use the finger, it doesn't let me.
Well, you gotta switch to the pen, knucklehead. You have a pointer. There you go.
Ah! I did it.
Technology drives them right to the street. Look at that, I might be a line on the board.
I don't like that.
Now I'm erased. This is slicker than whale dung in an ice floe.
Oh, of course. Okay. Ln y.
Whoa. That's a big jump there, Hoss. Slow your roll. Throw that extra step in there for us uneducated.
I see, okay.
That's better. I feel good there. Okay.
Alright.
Those are so good.
Now we move it out in front.
It's okay. This would be a surprise.
He's got it.
Is there a problem?
Yeah, finish that line.
Okay.
No. Plus.
Wait. Plus what? I'm not plussing. What am I plussing? Huh?
Rhymes with Smodic Pool.
I don't remember. I remember watching that documentary.
There you go, thank you. Let's see if you can pull it slowly and land the plane or if you do it right.
I don't. What would you want me to do? I mean. It's just two. What, you want me to like... Adrian, you mind coming up?
Oh, no. I gave you a clue.
Is that plus?
Plus,
What a plus is, you're good.
plus what?
Rhymes with Smodic Pool. What?
No,
Well, what?
I don't know.
Lily, tell me what you should do.
What should I do?
It's the product rule. So you have a great first part, 2x, and then the derivative of the natural log of x. So then if you want to get the natural log of x and then the derivative of 2x.
Okay, stop, let it go now. He's got it. Let's see if we can figure it out.
That,
Okay, Sully, bring it home. Send out the escape slides. The inflatables.
This isn't what I had.
Gotta land in the direction.
Now what?
I was just going to ask you that.
Okay. I can simplify this.
Oh, yeah, that's one step. Good. Yeah. Uh-huh. Oh, good. Good. Yeah. Yeah. Uh-huh.
Okay.
Almost done.
And then you put the right. Let's move it up. We'll go up here. See that?
Where'd your X go?
Where did the X?
Almost there.
And then.
You got this.
Put
Come
that
on.
into the right.
So what year is it? Like to see my grandkids. Wait. It's every education in the world. Yes! Okay, so this is the exact same thing as this, just a different function. Take the natural log of both sides. Use your log properties. Log property says you can bring the exponent out in front. Now this becomes a product rule. That's what many of you missed. Product rule. First times derivative of the second plus derivative of the first times the second. Multiply both sides by y. Sub back in for y. You're done. Okay? Unlike this problem, where you could do it with the stuff that you already know, I don't know if you'd know how to do that one without logarithmic differentiation. A function raised to another function. Okay. One last little thing here, and that is, if you're taking the natural log of an absolute value, it does not matter. Now, why doesn't it matter? If u is a negative quantity, and you're taking the absolute value of it, it's going to make it positive. If you think about the graph of a natural log, it's always positive anyways, so it doesn't affect the outcome of the derivative. Okay, good, got it? Right, those are natural logs. They're logs that are natural. They're natural. Go. I'm typing in Google artificial logs that look like natural logs. Go ahead.